Good evening. Today I would like to explain my conference title is Advanced Prediction and Detection of PFAS in Groundwater, a comparative study using extended convolutional neural networks and extended recurrent neural networks. And this is Dr. Asadi. I have completed my PhD with the specialization artificial intelligence at the Indian Institute of Information Technology, and my supervisors are Professor Anupam Agarwal, Dr. Alvin Lal, and Professor Ravi Naidu. And welcome to this conference. And these are the contents I would like to explain: abstract, introduction, objectives and goals, methodology, proposed architecture, performance metrics, results, discussion, conclusion, references. Coming to abstract, so here I am using groundwater contaminants in order to predict PFAS, that is the contaminants, the concentration levels of PFAS contaminants in the groundwater. I'm using two prominent technologies in deep learning concept like ECNN and ERNN, extended convolutional neural networks and recurrent neural networks. These algorithms are used to predict PFAS and contaminant concentrations in groundwater by showing ERNN's is a superior, better performance in terms of accuracy and robustness of ECNN algorithm. Then coming to introduction, so we have collected various literature survey papers related to deep learning techniques. The study compares with ECNN and ERNN techniques to enhance PFAS and contaminant prediction and detection in groundwater, addressing data limitations, modeling, generalization and interpretability. Then coming to objectives of my conference paper is to improve PFAS detection prediction in groundwater using ECNN and ERNN models to enhance accuracy, robustness and practical applicability for environmental management. Then methodology, there are various steps we are following in order to perform groundwater prediction and detection. The research employs ECNN and ERNN models with advanced data pre-processing, augmentation and hybrid feature extraction. Techniques to predict PFAS in groundwater evaluated using mean square error and R square metrics. And this architecture is nothing but structure which comprises the hardware and software components and connections among them. By integrating this enhanced convolutional and recurrent neural networks to predict PFAS concentrations or contaminants in groundwater using advanced layers for better accuracy and robustness. And this is the architecture we are using. We are training with 70% of the data, input data, and 25% for testing, and we are choosing the best machine and deep learning models. Finally, we are getting the concentration levels of groundwater. Then this is the data set we have collected with the columns like sample ID, latitude, longitude, depth and temperature, pH, conductivity, dissolved oxygen, nitrate, PFAS, PFOA, PFHSX, total PFAS, airport distance, industrial area distance, agriculture area distance, urban area distance, etc. And then performance metrics like ECNN and ERNN models was evaluated using mean square error and R square metrics. So these are the various metrics we are performing. Our performance metrics predicted ERNN is a superior accuracy with lower MSE of 3182.49 and a higher R square value of minus 0.069 compared to the ECNN model. That means ERNN is showing the better accuracy in terms of MSE and R square, which had an MSE of 4155.57 and R square value of minus 0.396. And finally, we are comparing with results shows the ERNN model has a lower MSE of ECNN model, which had MSE of 4155.57 and R square of minus 0.39396. And these are the graphs between predicted and measured for ECNN model and as well as ERNN model prediction. Then finally, the experimental result shows that the ERNN model consistently outperforms the ECNN model in predicting PFAS concentration or contaminant concentration, demonstrating the benefits of using recurrent neural networks with attention mechanisms for better accuracy. Then the comparison of existing and proposed system with various parameters like model type, primary focus, data utilization, feature extraction, maximum mean square error, maximum R square value, prediction accuracy, robustness, interpretability, overfitting risk, etc. So proposed system like ERNN, it is outperformed than in all the cases of ECNN. Then future direction, we are integrating with more deep learning techniques with higher frameworks and hybrid models to improve PFAS detection, accuracy in groundwater and expand to other pollutants and regions, etc. And then conclusion about my experimental results analysis shows the ERNN model outperforms the ECNN model in predicting PFAS concentrations in groundwater with lower MSE and higher R square values, demonstrating better accuracy and robustness. These are my references for this my conference paper, and thank you for giving me this wonderful opportunity.